Good morning, one and all. Welcome to my classroom. I am Reshma C., Assistant Professor, Department of Civil Engineering, SNIT, Adur. In the previous class, we were working out more numericals from each modules. In today's class, we will be discussing 3 university question papers of KTU. First question, a rectangular concrete beam 250 mm wide and 600 mm deep, that is B and capital D are given, is pre-stressed by 4 cables with 7 wires of 5 mm diameter located 150 mm from the soffit of beam. Soffit means at the bottom. If effective stress in the wires is 850 Newton per mm square, what is the maximum bending moment that can be applied to the section without causing tension at the soffit of the beam? So for this question, you have to find out P by A, PE by Z and M by Z. Write down the equation for stress at the soffit of the beam and find out M by equating the equation to 0. This question carries 15 marks. B part of the question is to write down the advantages of pre-stressed concrete members over reinforced concrete members. For this question, you have to write down at least 5 points since this carries 5 marks. The points should mainly include that the entire section of the pre-stressed concrete beam takes part in resisting moment. It eliminates corrosion of steel when the structure is exposed to weather. Then, since there is no cracking in a pre-stressed concrete beam, its behavior can be explained in a more accurate manner. Then, in pre-stressed concrete, the sections are much smaller than those in RCC, as the dead load moments are neutralized by the pre-stressing moments and shear stresses are reduced. Then, that the pre-stressed concrete has the ability to resist impact and shock loadings. Therefore, it can be used for the construction of road and railway bridges. Also, it has got high fatigue resistance and live load carrying capacity. Now, moving on to May 2019 question paper. The first one is discuss in detail the losses involved in pre-stressing. It was asked for 5 marks. In this, we have to list out all the losses as well as explain each loss with its equation to score full marks. Now to the B part. A post-tension cable of a beam 9 meter long initially tensioned to a stress of 1000 Newton per mm square at one end. If the tendons are curved so that the slope is 1 in 24 at each end with an area of 600 mm square, calculate the loss of pre-stress due to the following data. First one, coefficient of friction between duct and cable is 0.25. Friction coefficient for wave effect is 0.0091 per meter. During anchorages, if there is a slip of 3 mm at the jacking end, calculate the final force in the cable and percentage of loss due to friction and slip, given yes. Similar question was worked out in a revision lecture. So in this case, we have to find out the loss due to friction, due to slip, the total loss and percentage loss, and finally the final force. Moving on to the next question. A part, explain the principle of pre-stressing, which we have already discussed. It is asked for 4 marks. In the B part, explain the reasons for using high strength materials in pre-stressed concrete. Here you have to specify the need for high strength concrete as well as the need for high strength steel. Each carries 3 marks, together 6 marks. Now the C part is a rectangular concrete beam 250 mm wide and 550 mm deep is pre-stressed by means of 4 numbers of 12 mm dia high tensile bars located at 200 mm from the soffit of beam. If the effective stress in the wire is 700 Newton per mm square, what is the maximum bending moment that can be applied at the soffit of the beam? It carries 10 marks. In this question, you can find out the total moment using the equation P by A plus PE by Z is equal to M by Z. There, the M is the total moment, that is the moment due to dead load as well as the external moment. So, in order to get the external moment, you have to subtract the dead load moment from the total moment. Next is the questions from December 2019 question paper. First one is to differentiate between pre-tensioning and post-tensioning. It was asked for 5 marks. Here you may write any 5 relevant points. This topic is already discussed. Now the second question, determine the extreme fiber stresses developed at the midspan section of a simply supported pre-stressed concrete beam of rectangular section 250 mm by 600 mm, pre-stressed using high tensile steel of cross-sectional area 1000 mm square, stressed to 1500 Newton per mm square. The center of gravity of steel is 150 mm above the soffit of beam. Superimposed load is 16 kN per meter. Span of beam is 12 meter. Draw the stress diagram at midspan. In this, you have to find out P by A, PE by Z and M by Z. Find out the total stress at top as well as bottom fiber. Then you have to draw the stress diagram. Next question is to explain the various losses of pre-stress. In this, you have to list out the various losses as well as explain each loss along with their formulas. Now the next question is a pre-stressed concrete beam 250 mm wide and 350 mm deep is pre-stressed by 12 wires of 6 mm dia located at an eccentricity of 40 mm and carrying an initial stress of 1500 Newton per mm square. The span of the beam is 8 meter. Calculate the percentage of loss in wires if it is pre-tensioned. ES and EC are given. Relaxation of steel stress is 5% of the initial stress. Total shrinkage strain is 200 into 10 raised to minus 6. It is asked for 15 marks. In this, you have to find out the loss due to elastic deformation, loss due to relaxation of stress in steel, loss due to shrinkage, then sum up to get the total loss and find out the percentage loss. With this, we wind up the discussion of university questions of 6th module. In the next class, we will work out more numericals in 4th module. Thank you.